This is my work energy reassessment. My problem is you push a 15 kilogram box of books 2.0 meters up a 25-degree incline into the back of a moving van. The box moves at a constant velocity if you push it with a force of 95 newtons. A, find the work done by the normal force on the box. B, the work done by your push on the box. C, the work done by gravity on the box. And D, the work done by friction on the box. Assume your push is parallel to the incline. So, drew my free body diagram of the box, the normal force, the force of the push, the friction force, and the gravitational force. And so our work is equal to the force times the displacement times cosine of theta. So now for the work of the normal force, we would plug in here, but because the angle is 90 degrees, that would make this 0, so therefore the work of the normal force is 0, so there's no work done. The work of the force, the pushing force, is equal to 95 newtons times 2.0 meters times cosine of 0, which cosine of 0 is 1, so the force you exert when you push is equal to 190 joules, and so then it wants the gravitational force, and so the work of the gravitational force is equal to 15 kilograms times 9.8 meters per second times 2.0 meters times, and we'll use cosine of 245 for this angle because we'll just assume, but it would probably be in the third quadrant, which would make it negative, which when you multiply all this out, we get a negative work. So the work of the gravitational force is negative 124.25 joules. So the total work is equal to change in K. And so the total work is equal to the normal force plus the force of the push plus the friction force plus the gravitational force. So we're solving for the friction force. So we move this over here, and because since total work is equal to 0, so we're solving for the frictional force, so we move everything over, rearrange, and then we plug in what we know. Our normal force is 0, and then our work of the force on the push is 190, then our work due to gravity is negative 124.25. Make sure you watch the minus signs, or the negative signs and the subtraction signs. And once you have everything, you add it up together, and then we're given the work of the friction force is negative 65.75 newtons.